didn't see it, this video really doesn't do it justice, because it takes all the 3D work that I've done and flattens it back into 2D. But it's a good document as to a general sense of the idea. And actually, my colleague Matt Sharper is sitting in the audience, and he's helped out with a lot of the programming and come up with some very interesting, innovative ways to do this. But really, what this was for me, this was proof. This was proof to me that if you get digital content in real 3D space, it's like very, very intriguing. Like your body gets peaked, right? Like it's proof to me that I want digital content in real 3D space, and in space that's measurable. You know, I don't want to actually, for my purposes, for the purpose of trying to get my body into cyberspace, for bridging that gap, I don't want stereoscopic vision. I don't want to have to look through some portal or I don't want to have to do all these weird things. I just want real space. And what does that mean when digital content is in real space? How do we create this real space and make it interesting, I guess? But after this, and we're continuing to develop this project, but this question came up over and over in my head that this doesn't get my body into digital space. What this is doing is it's taking digital space and printing it in real 3D space, which is cool, don't get me wrong, but I wanted to still get my body into digital space. And I did a lot of research and tried to figure out some design patterns and tried to leverage my understanding of existing technologies to imagine what that might look like. And that is the project that I'm mostly going to be talking about today, which is spatial computing. And this is a series of design sketches that sort of explain what it might feel like, what sort of design patterns we're going to have in three-dimensional space, how they're going to be different from 2D space, and how they're going to be similar. So I'll just let you guys take a quick look at it for now.
This store happens to be very well stocked in coffee tables. There are so many, in fact, that we can't see all of them at the same time. In order to move this display case around so that we can get a better view of the other coffee tables, we're going to have to do another gesture. Pinch using your thumb and index finger, and drag your hand back and forth to move this display case around. So let's say we found a coffee table that we really like. Now that we found the product, we get to try it out. And this is where shopping with spatial computing gets really exciting. To try out the product, just select it. Look at that. You got a full-scale 3D model of this coffee table just sitting in your living room right next to all the other furniture that you already own. We didn't need to pull out any measuring tape. We don't even need to know how many inches are in a foot. And we'll still be able to tell, just from looking, whether or not this coffee table will fit nicely in our living room. If you want to check out different colors of the coffee table, you can select it from this menu here. And if you want to move this coffee table around and try out different arrangements, just click and drag. To be a little more accurate, you can pinch and drag with a finger. Or if you need to rotate it, pinch and drag with 2 fingers. Look at that. Arranging furniture has never been easier. No heavy lifting, no assembly required. If you want to arrange some more furniture, you can find all the pieces of furniture that match this particular piece and pull them down from the display case. Arrange them as you see fit, and if you're done with any of them, just put them back. Cool. If you're ready to purchase a product, all you got to do is drag the product over to your shopping cart over here and click on the shopping cart now that you're ready to purchase.
Great. So this project for me is like, how do you create environments that are as real as the environments that we live in, that we exist in? This room is like very real to many of us. We have many reasons why it's real to us. I'm going to talk about our perceptions of that right now. In the process of studying interaction designs for this video, I took a lot of my inspiration from 2 different types of interaction design. One being how we interact with digital two-dimensional content, and how we interact with conventional three-dimensional content, to figure out how we can interact with digital three-dimensional content. And I think it's important to identify that when you're talking about translating 2D interactions into 3D interactions, you have to parse out, you have to split it up into two different parts. Take every interaction and say, this is the functional behavior that's required, and this is the dimensional relationship that needs to happen just because we exist in that space. Does that make sense? So, for example, a hover state on a computer screen. Oh yeah, cool, like this, right? So we have this mouse here, right? And we have these arrows down here that have importance because they're on black. And obviously I want to hover it. And basically the hover state functionally is telling me, hey Albert, I think you want to touch this. Like if you were to click right now, this is what you would be activating, right? That's a functional thing. But the two-dimensional aspect of it is that now two-dimensionally, we are overlapping the cursor with the icon that we're about to select, right? Being able to split them up functionally and dimensionally, once you do that, you can just throw out all the two-dimensional stuff and reinvent it when you get to 3D, right? And the next part was how do we interact with conventional 3D content? And this is a really weird question because when you talk about 3D interaction design, nobody thinks of not computers, right? Everyone always is like, 3D interaction design, it must be computers, right? But there are so many instances of 3D interaction design that we have on a daily basis. I shake your hand, I get up, I brush my teeth, right? These are all sophisticated manipulations that I don't think we should take for granted when we're trying to figure out how computers can do that. So how do 2D spaces and 3D spaces differ? I'm going to go through this list twice. The first time I'm going to talk about just conventional spaces, and I'm going to go over the list again and talk about how they differ in 3D spaces, in digital spaces. So they're very, very different. The way we manipulate objects in 2 dimensions and in 3 dimensions are very different, and the way we identify things or communicate in these spaces are very different. All right. So first of all, perception. First of all, let's talk about here a couple 2-dimensional things in real life that you might interact with, right? Just take a quick look at this and think about the breadth of scale. And maybe there are a few other things that, maybe a billboard or something, or try to imagine all the 2-dimensional things you interact with. And then think of all the 3-dimensional spaces you interact with, right? We're talking magnitude, orders of magnitude different, right? A plastic bag, where's my phone? It's in my pocket. And then where are we? We're in Orlando. Where are we? Contextually, that shifts very differently. And 3D spaces, first encountering it can be a little overwhelming, but there are a lot of experts out there, architects and dancers and stuff that I think have some keys. So in terms of 2D perception, first of all, it relies on the eyes, right? We see 2D perception with our eyes. We don't really touch it, because if we touch it, it's texture, and that's not really 2D. It's contained by a frame. I know that in a theoretical sense, 2 dimensions is a plane that extends in all dimensions infinitely, but in practice, when we interact with 2-dimensional content, it's always in a frame. And being 3-dimensional beings peering into the 2nd dimension, we get to see all content, always. Nothing is occluded. It's very rare that you're going to be looking up in this corner of the screen and missing something entirely down here, where in 3D space it's sort of different, right? And yeah, that's this note's sort of the same thing. We have an omniscient point of view, outside-in perspective. In 3D perception, it's very different, right? In 2D perception, when we receive input from whatever we're looking at, we look at it. In real 3D spaces, we have a bunch of different senses because we had to once run away from tigers that were chasing us down, right? We have this cool apparatus called the human body that gives us way more information. Not just our eyes, right? We hear something in the distance, we know where it's coming from 3-dimensionally. We can touch things, and we can probably smell things. I think that when I'm walking down the street and I smell something, and it's kebabs or whatever, I know where it's coming from. We have this sense called proprioception, which is the ability for us to know how our body is shaped. So if you were to knock me out, put Novocaine all over my body, and blindfold me, I'd wake up like this, and I'd be able to tell you, how my body's shaped. It's just this sense that we have, right? And then I listened to this recent Radio Lab episode, which if you don't listen to Radio Lab, you absolutely should, but it's about location, and apparently our brains, we have grid cells, we have border cells, and we have head direction cells, and these things that, we have a lot of very sophisticated equipment to perceive three-dimensional spaces. The scale of our attention is highly elastic. In 2D space, conventionally, you're looking at something about this big, right? In 3D space, though, like, hey, everyone look right here, right? That's like an inch. And you're focusing on an inch. Everyone in this room is focusing on an inch. But think about this whole water, right? Like, think of the orders of magnitude the difference between that inch and this ball group. It's really overwhelming at first, and I think a lot of designs that I've seen, 3D designs that I've seen, they just sort of forget this. They just think in one space, and they just forget that our attention grows and shrinks elastically. And likewise, and because of this, we're easily distracted. It's very easy to look at that, to have our focus pulled over here and totally miss things. And we constantly have, and because we're totally distracted, we have to constantly filter out information. And lastly, being three-dimensional beings, existing in a three-dimensional universe, we have a subjective point of view about the world. We can't look top-down like we look into two-dimensional planes. We have a very subjective point of view. In terms of two-dimensional manipulation, if I were to put like a card on the ground and slide it around, I'd use a finger and drag it. I could use a couple fingers to rotate it. And I could also